next. NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish.
NASA's Voyager 1 and 2 of humanity's most ambitious space missions have just sent back data that could change everything we know about the universe. What they've discovered at the very edge of our solar system is sending shockwaves through the scientific community, with implications that go far beyond the boundaries of space exploration. The most shocking revelation? An entirely new magnetic field, one that was never predicted, and one that could force us to rethink our understanding of the entire interstellar environment. Imagine this. The sun's magnetic influence was thought to fade as the spacecraft crossed into interstellar space. But instead, Voyager has encountered a magnetic force stronger and more complex than anyone anticipated. This unexpected find isn't just a scientific curiosity. It could have major implications for the way we understand space travel, the protection of our planet from cosmic radiation, and even the very nature of the universe. And while NASA is scrambling to decode this discovery, the implications for humanity are far-reaching. If the interstellar magnetic field is as significant as Voyager data suggests, it might open up new avenues of exploration and even survival strategies for space colonization. But if it's part of something more dangerous, something yet unknown, we could be facing an unforeseen threat. This discovery is timely as SpaceX and other private space ventures are on the verge of establishing a human presence in deep space. What does this new information mean for our safety, our technology, and our future? For decades, the Voyager missions have been humanity's eyes on the farthest reaches of space. But what they've uncovered at the boundary of the solar system has upended everything we thought we knew. Voyager 1, now more than 23 billion kilometers from Earth, passed the heliopause, the point where the sun's influence ends, in 2012 and entered the vast expanse of interstellar space. But what it found was not the quiet, empty void that scientists had expected. Instead, it encountered a dynamic environment full of unexpected phenomena that could change the future of space exploration forever. The most shocking discovery came in the form of cosmic rays, high-energy particles typically associated with violent events such as supernovae and black holes. Scientists had long believed that the solar system acted as a protective shield, deflecting much of the cosmic rays that permeate space. But Voyager's instruments detected an alarming increase in the intensity of cosmic rays as it crossed the heliopause, suggesting that this shield wasn't working as expected. This wasn't just a small anomaly, it was a significant spike, one that scientists were not prepared for. This unexpected change in cosmic ray levels raises disturbing questions. Are we really prepared for the harsh conditions of space beyond the protection of our sun? Could these unexpected levels of radiation pose a threat to future interstellar missions, particularly to astronauts venturing far beyond Earth's orbit? What else is out there in the interstellar medium that we haven't even considered? These cosmic rays may just be a symptom of a much larger, invisible force lurking in deep space. And if so, it's something for which humanity is woefully unprepared. NASA and other space agencies are urgently investigating these measurements. But with private space companies like SpaceX pushing towards Mars and beyond, this is no longer just a theoretical concern. With each passing year, we get closer to sending humans into space for extended periods of time. But this new data points to dangers that no one anticipated, forces in the deep unknown that may be far more threatening than anyone realizes. NASA's commitment to exploring the outer reaches of the solar system is no longer a matter of curiosity. It's a matter of survival. The unprecedented data Voyager has sent back about the behavior of the heliopause, the boundary between the sun's protective bubble and interstellar space, is shaking everything we thought we knew about the dynamics of space. But as this discovery deepens, so does the need for a more advanced strategic response. For decades, scientists believed that the heliopause, where the solar wind from the sun meets the interstellar medium, was a smooth and well-understood boundary. But Voyager's findings revealed something far more complex. Instead of the expected gradual decline of the solar wind, Voyager has revealed bizarre magnetic and plasma fluctuations that defy current models. These unexpected shifts point to forces we can't yet explain. Forces that could have profound implications not only for space exploration, but also for the security of Earth. NASA, with its vast network of specialized technology, is now charged with unraveling these mysteries. The agency's unique position, with its vast experience, unprecedented data gathering capabilities, and sophisticated modeling systems, makes it the only entity capable of leading this investigation. From the ultra-sensitive instruments aboard the Voyager spacecraft to the supercomputing power used to process data in real time, NASA is the only organization with the resources to turn these unexpected findings into actionable knowledge. But it's not just the data collection that sets NASA apart. It's their strategy for unraveling the true nature of the forces at play. Their mission is far from over, with a series of follow-up maneuvers planned to track changes in the interstellar medium and gather more detailed measurements of magnetic fluctuations. Using its expertise in space physics, NASA plans to simulate the interactions between the heliosphere and the interstellar environment and create models that could predict the potential risks of this new behavior. They're already preparing for a series of groundbreaking missions to be launched in the coming years to probe deeper into the interstellar space that Voyager has only just begun to explore. But even with NASA's capabilities, these unknown magnetic forces pose a significant challenge. If these forces are as powerful and unpredictable as they seem, they could affect future space missions, potentially jeopardizing the safety of astronauts venturing beyond Earth's protective bubble. And what if these fluctuations in the heliosphere are just a symptom of something much larger? Something that could affect the entire solar system? Voyager's recent discoveries in the outer reaches of the solar system are forcing scientists to confront a frightening reality. We may not fully understand the forces at play in space. The spacecraft's instruments have detected anomalies in the space between stars, phenomena that can't be explained by current scientific models. These unexpected interactions between solar wind cosmic dust and the interstellar medium hint at the presence of unknown forces, forces that could have profound implications for the future of humanity. The findings are particularly alarming because they suggest that what we thought we knew about space, our solar system's protective bubble, and the behavior of cosmic elements is far from complete. Voyager's instruments have picked up irregularities that suggest a complex, previously unknown interaction between solar wind and cosmic dust particles, disrupting the smooth flow of matter at the edge of our solar system. This could indicate the presence of a previously unseen force, potentially affecting everything from how we protect spacecraft to how we view the interstellar environment as a whole. The global implications are vast. If these unexpected forces prove to be more dangerous than anticipated, they could pose a serious risk to any future space missions, especially those beyond the protection of Earth's atmosphere and magnetic field. With NASA and SpaceX both planning long-term missions to the Moon, Mars, and potentially even beyond, these new revelations force us to consider how vulnerable our technology and astronauts might be to this unknown cosmic threat. Yet the discovery is not entirely negative. Understanding these new forces could revolutionize space travel by offering insight into the true nature of the interstellar medium, perhaps even opening doors to new propulsion methods or ways to protect astronauts from harmful radiation and cosmic dust. If scientists can harness this newfound knowledge, humanity could be prepared for an era of interstellar exploration previously thought to be impossible. The rise in cosmic ray intensity at the edge of the solar system is not just a scientific puzzle. It's a high-stakes game that could reshape the future of humanity. As Voyager 1 and 2 send back data showing an alarming increase in cosmic ray levels, scientists are beginning to face a chilling reality. Our solar system's protective shield, the heliosphere, may not be the safeguard we thought it was. And this is not just a problem for space explorers. It has profound implications for life on Earth, our technology, and even our future survival in space. If the heliosphere's protective effect is weaker than expected, the intense radiation from distant stars and cosmic events could penetrate much deeper into our solar system and potentially reach Earth. This means that the risks to astronauts traveling to Mars and beyond are greater than we realized. radiation exposure could have devastating health effects, jeopardizing long-term human space missions. These missions, critical to SpaceX and NASA's plans, could be significantly delayed or even abandoned if scientists cannot find ways to mitigate this radiation. But the risks don't end with space exploration. The increase in cosmic rays could also affect Earthbound technologies. Satellite systems, GPS networks, and communications could all be affected by increased radiation, leading to disruptions in everything from global communications to military operations. The increased radiation could damage infrastructure and even threaten the safety of everyday life on Earth. Imagine a world where the technology we rely on for everything from navigation to weather forecasting suddenly becomes unreliable, all because of this invisible force from deep space. This situation also raises enormous ethical questions. As we push the boundaries of space exploration, should we consider the protection of those who will be the first to venture into this dangerous territory? Should space agencies be held accountable for the risks posed to astronauts? Moreover, the prospect of space colonization, something many have dreamed of, now takes on a darker tone. What does it mean to send humans into a dangerous and poorly understood radiation environment? What moral responsibilities do we have to those who will follow in the footsteps of Voyager and explore beyond our solar system? But there's more at stake. If the heliosphere is found to be weakening, it's possible that we're witnessing the beginning of a larger cosmic event, something that could affect not only space travel but life on Earth. Could these rising radiation levels be part of a wider, looming cosmic event that we're only beginning to understand? Could this be the catalyst for a new era of space threats for which we're unprepared? Long past their prime, the Voyager missions continue to defy expectations, particularly in the area of communications. This extraordinary feat of data transmission, especially given the age of the spacecraft and the challenges of the interstellar medium, has raised eyebrows among space experts and engineers alike. The question is, how is this possible? And what does this unexpected performance mean for the future of space exploration? Experts in the field of space communications initially predicted that as Voyager's distance from Earth increased, the data transmission rate would decrease significantly due to the fading strength of the spacecraft's signal. However, recent data shows that Voyager 1 is still sending back vital information at a much higher rate than expected. The spacecraft is still operating at a modest 160 bits per second, compared with the original rate of 15,000 bits per second. But at such distances, this rate is still astonishing. A feat like this pushes the boundaries of what we thought was possible in deep space communications. One of the key reasons this is happening is due to the spacecraft's communication technology, which was designed to survive and transmit for longer than expected. Voyager's high-gain antenna is still functioning, sending signals to Earth with surprising clarity. This longevity is attributed to NASA's meticulous planning and an ongoing mission to improve the craft's ability to process and compress data for efficient transmission. As a result, even with a nearly 22-hour round-trip time for data signals, Voyager's high-speed performance is allowing for the continued discovery of invaluable information about the outer reaches of our solar system. However, this unexpected communication success has led to some intriguing predictions and potential outcomes. According to Dr. Edward Stone, a former Voyager project scientist at Caltech, the continued success of the Voyager missions in terms of data transmission is one of the most impressive accomplishments in space exploration. We are now learning more about deep space with each passing day. What makes this even more remarkable is that such performance could serve as a blueprint for future space missions that venture into even deeper, more remote regions. If Voyager can continue transmitting for years to come, it could radically change the way we design long-term space exploration missions. On the other hand, there are potential downsides to this continued data transmission. For one, the reliance on the spacecraft's communication system for critical data may eventually become a liability. As the spacecraft's power reserves continue to deplete, its power supply is expected to run out by around 2025. The ability to send data back to Earth could be severely hampered. The spacecraft is already operating with limited power, using the last of its nuclear power source to keep its instruments active. Should the system fail, there could be a significant gap in the data collection process, leaving scientists without crucial information at a critical time. Voyager's voyage into uncharted space has already surpassed every expectation, revealing the uncharted regions of the interstellar medium with unprecedented detail. But as the spacecraft pushes further into the void, it is uncovering more questions than answers. An unsettling reality for scientists who thought they understood the edge of our solar system. What exactly is out there in the vast space between the stars? As Voyager continues to send back valuable data, it's still unclear what it's encountering because what it's finding contradicts everything we knew about interstellar space. Space beyond the solar system is far from the quiet, empty void predicted by scientists. In fact, Voyager's instruments have detected fluctuating magnetic fields, strange radiation patterns, and phenomena that suggest the presence of previously unknown forces and bodies. These unexpected communications with objects that shouldn't even exist have left researchers scrambling for explanations. One of the most tantalizing possibilities is that Voyager has encountered unidentified interstellar objects, or even an entirely new type of cosmic body, something that our current instruments and models have never been able to detect. This could be the discovery of something entirely new, perhaps a form of matter or energy not yet understood. But if these findings are real, they could change our understanding of the very fabric of the universe. And with it, the potential risks and benefits for humanity's future in space. The critical question now is, how do we prepare for what's out there? Could these unknown bodies pose a threat to future space missions, or could they hold the key to furthering humanity's reach into the stars? If Voyager's sensors are picking up interactions with things we didn't even know existed, what else could be hiding in the deep, cold, dark? And yet, amidst the excitement of the unknown, there's hope. If Voyager can continue to send back this kind of data, it could open up a new frontier in astrophysics and space exploration. This new frontier could hold the answers to questions that have puzzled mankind for centuries. Could this unexpected communication with interstellar objects lead to breakthroughs that will propel us into a new era of exploration? Or could it expose flaws in our understanding of space and place humanity in a more precarious position than we ever imagined? As Voyager ventures further into the unknown, one question remains. Could the forces it encounters herald something much larger and darker beyond our solar system? Or is it a warning of a cosmic threat for which we're unprepared? The stakes are higher than ever. The future of space exploration, and even our technology, could hinge on what Voyager uncovers next. What happens when it reaches its limits? Will we discover a new era of exploration or face an unimaginable crisis? Like, subscribe, and hit the bell for more updates. Don't miss the next video. What Voyager uncovers next could change everything.